Hello, everybody. Welcome to Bristal Better U. My name is Linda Maria Frank. I am the author of Tillery Mysteries. I am a former teacher of forensic science here at Hofstra, and I'm also the producer of The Writer's Dream, an interview show with authors. Today's topic is investigations in forensic science, those CSI programs, fact to fiction. CSI programs, what is it about them that makes them so popular? And they are the most popular TV shows. For me, it's because what happens is we get a sense of security because the bad guys get caught by using the technology that the good guys produce. And I think that is why people like to watch them. Some people say it's our obsession with crime, our obsession with the dark side, but I really think it's because we solve those problems and we use logic and we use things that are safe to do them. It all starts with protocols. What I'm going to do is I am going to talk about how forensic science should be carried out, and I'm going to let you figure out when you watch the shows whether or not you are seeing fact or fiction. Okay? So it starts with protocols. The first one is the isolating the crime scene. And we see that what happens is a crime occurs. Some of you have probably seen crime scenes. Oftentimes when there's a traffic accident, you will see yellow crime scene tape. And why is that with a traffic accident? That's usually because there's there is a fatality or a suspected fatality, and I have to decide whether or not this is going to be manslaughter, or vehicular homicide. But the first thing that has to happen there is that what we have to do is we have to isolate that crime scene. Why? Because we have to make sure that the evidence is not tampered with. How crimes are solved or how mysteries are solved, basically what we're talking about here is we start out with the crime scene. We have to collect evidence. Evidence is clues. We have to recognize the clues. We collect that evidence. We package that evidence. Then we take that evidence to a lab where we process the evidence and we use logic and we deduce a solution to the crime. That is how mysteries are solved. That is how crimes are solved. Most mystery stories are written based on how crimes are solved. So let's start talking about the evidence. Okay, what is evidence? Today's forensic scientists talk about physical evidence. And physical evidence, these are items that connect the perpetrator to the victim to the crime scene. It doesn't have to be all three, but it has to be at least two of those connected. We also define evidence as something that the labs can actually process. An item that has no test that can be done to it is not really evidence. Also, evidence is something that the crime scene unit is trained to pick up. Eyewitness accounts, for instance, are not good evidence. This is not considered physical evidence because, as we know, you get 6 people together to witness the same thing and they all see something different. So it's not really objective. What we want in a crime scene investigation is objectivity. Legal issues at the crime scene are something that really have to be considered very carefully. When you're watching CSI, NCIS, Criminal Minds, any of these shows, Law and Order in particular I think is very good because what they do is they do address the whole idea of the legal issues at the crime scene. We have a system that's based on innocent until proven guilty. And because of that, we have many safeguards. A lot of people will argue that the criminal has more rights than the victim, but you have to keep in mind the idea that you do not want to put innocent people in jail. So the first thing that we talk about is Mirandizing. And of course, we know that when someone is apprehended at a crime scene or arrested, the first thing that happens is they get read their rights. And that's based on a case, Miranda versus the federal government. There are actually 3 organizations here that are involved in solving a crime and also prosecuting a crime. First of all, it's the police department. It is the purview of the police department to go to the crime scene, isolate it, protect it, collect the evidence, analyze it, and present the findings to the district attorney's office. The district attorney's office will prosecute the case, try to convict the criminal, and they also have to disclose this evidence to the criminal's attorney. The defense attorney, it's his job to represent the accused, the defendant, and make sure that the defendant gets a fair trial. We have a lot of cases where innocent people are put into jail for because they're either the legal system failed somewhere, or the evidence was not processed properly, or it wasn't collected properly. What you see on television is the best of what happens in the forensics world. You don't often see what goes wrong. Not every police department and not every district attorney's office does a wonderful job all the time. Okay, here's another safeguard against having a case go wrong. This is called chain of custody. Chain of custody is really a series of paperwork that's filled out by everybody who touches the evidence. At the crime scene, what will happen is the crime scene investigation unit has special packages for all kinds of evidence, which we'll talk about in a little while. Every piece of evidence has a piece of paper that goes with it, and you're seeing it on the screen. That's a chain of custody form. The person who collects the evidence signs their name and dates it. The detective who is assigned to the case gives it a case number. He signs his name. It goes to the lab. In the lab, there's a room where they take all of the evidence and distribute it amongst the various departments in the forensics lab. That person signs it. It's given a locker, and it's locked up in that locker. Every person who takes that piece of evidence out of that locker has to sign the chain of custody form. And the purpose behind that is to make sure that what's collected at the crime scene ends up in court, no more, no less. There are a lot of novels that are written, crime novels that are written, where chain of custody is not carried out. It's tampered with. Somebody who has access to that locker, that evidence locker, can get in there and either put things in that don't belong there or take things out. It makes for very good stories. Okay, the Fourth Amendment is unreasonable search and seizure in order to make sure that everybody's rights are protected. The detectives have to get, the police department, they have to get search warrants in order to collect evidence. This is oftentimes what happens when a case really can't come to court. You'll have a criminal case, a crime has occurred, the police have arrested somebody, but what happens is they did not get a search warrant, and they collected evidence or took things away from a crime scene or a person's residence without that search warrant, and when that happens, the case is thrown out of court. And what you'll find in a lot of criminal cases is that the defense attorneys will look very carefully at all of these rights. Fourth Amendment, chain of custody, they're looking for places where they can get the evidence thrown out. Even if they can get one important piece of evidence thrown out, the case does not go to court. The case could go to court, but it will really weaken the DA's case. Now, there are two decisions, very important decisions in forensic science. One of them is called the FRA Decision, and this has to do with the admissibility of evidence into court. What can both sides, defense attorney and DA's office, what can they actually submit as evidence? The FRA, and also analysis techniques. The FRA decision says that if the scientific community, the respected scientific community, respects the test, then the evidence and the test is admissible. This was taken a step further by the Lindbergh Case in the Federal Rules of Evidence. The Federal Rules of Evidence just ensure that the usual scientific safeguards, such as using controls, using standards, that these are adhered to so that we don't have any junk science going on. So these are, again, to protect what can be brought into court. So your crime scene investigation units actually need to be conversant with this, and also the labs, so that they adhere to that. If these standards are not adhered to, if your defense attorney or your prosecuting attorney can come up with the idea that these scientific tests do not adhere to Fry and Daubert, then the evidence can be thrown out. So these are all safeguards. So let's get started with working the crime scene. Okay, what do we have to consider at the crime scene? Well, first of all, safety. What happens sometimes, crime scenes can be very chaotic. The police can get there while the crime is still going on, or they can get there when there are people who are injured but not dead. And so what has to happen is the first rule is to get the people who are injured, to get them help. So what happens in the crime scene is a lot of evidence can get trampled by the EMTs who come in. So once we get those people out, if in fact there are injured people, then the next thing that has to be done is we have to secure it. And a police officer, they put the yellow tape around, the police officer comes in, he protects that crime scene. Then the crime scene unit comes in and they start processing the crime scene. And this is when you see all those people in white suits. Why do we have people in white suits? The reason for that is because there's a principle in forensic science called the Locard's principle. And Locard was a Frenchman in the 1800s who said, and this is one of the most important concepts in forensic science, there is a transfer of materials from the perpetrator to the victim to the crime scene, some way or other. So that's really the basis of collecting evidence. You're looking at a crime scene, you're seeing a victim, and you're thinking to yourself, okay, what did the perpetrator leave here? What did he leave here that could help us to solve that crime? Okay, here we see some of the items that the crime scene unit uses. Basically, what you're seeing is specific items that will collect things like fingerprints. You've all seen shows where they're dusting for fingerprints. And if your house has ever been broken into and the police have come, they make a real mess of your house with the dusting powder that they use for fingerprints. There are rape kits, so that if someone is raped and they go to the hospitals have kits where they can collect materials from underneath the fingernails of the victims, vaginal swabs, saliva, blood, all that kind of evidence that could possibly find the perpetrator of that crime. In an arson investigation, there's a special instrument called a sniffer, and what a sniffer will do is it'll pick up fumes from accelerants, because many arson crimes are started by dumping gasoline or kerosene on the scene and lighting it up. There are special ways to collect blood at a crime scene. There's special ways to collect DNA and hairs and fibers. Hairs and fibers are interesting. Usually what happens is if there is a victim, any victim, what they do is they take the clothing of the victim and you could just use a credit card, and they scrape the clothing onto a piece of white paper, and then the technician has to separate all of the hairs and fibers and try to find out what belonged to the victim and what possibly didn't belong to the victim that might belong to the perpetrator. This is, I think, really interesting. These are two, to me, of the most interesting cases in forensic science. The first one is Sam Sheppard. You may remember that. This is a trial that goes back to the 1950s. Sam Sheppard was accused of the murder of his wife. His wife was brutally murdered. He was having an affair. They were estranged. They were ready to get a divorce. And he was accused and eventually convicted of the murder of his wife. This is the basis for that long-running TV show, The Fugitive, and the movie as well. What happened was he spent a lot of time in jail, but his son, when his son became an adult, decided to try to get his father. He believed in his father's innocence, and by that time they had developed DNA technology. And the DNA technology was used because the evidence had been saved, and it showed that there was truly another person at the crime scene other than Sam Sheppard. Sam Sheppard lived there, so he kind of belonged there. And so he was proved innocent, but he died. I mean, I believe he died before he was proved innocent by his son's work. Very, very sad. We also know about the Innocence Project. The Innocence Project was started by a bunch of law students who were looking into various cases where the person who was incarcerated was still adamantly saying, I'm innocent, I'm innocent. So they decided to take the evidence, and we know that the evidence is saved in many cases for years. And they subjected it to DNA evidence, and we have found, I think it's like up to over 50 people have been exonerated of those crimes, and because they were convicted, again, on eyewitness accounts, which are unreliable, but the DNA evidence showed that they were not the criminal in the case. However, we also find on the right side of the slide the O.J. Simpson trial, where the DNA evidence, which is wonderful technology for criminologists, showed O.J. Simpson to be at the crime scenes. Let's put it that way, and actually other factors came to play. Okay, what can go wrong? This picture kind of says it all. In the O.J. trial, I have to say that this is what went wrong. The defense attorneys, who were called the Dream Team, attacked the evidence. They started out with attacking the procedures of the crime scene investigation unit, and they also called expert witnesses on that kind of evidence collection, and they flustered a man named Lee. I cannot remember his first name, but he is a famous blood evidence expert, and they absolutely rattled him, and he actually said something that was wrong. They also attacked the technicians, so they attacked the evidence. And then eventually what they did, which really swung the case, was that they impugned the integrity of the lead detective. The lead detective's name was Mark Furman, and they showed that he lied on the witness stand about using the N-word. And so what happened was the jury decided that if they could not trust him on that issue and that he lied on the stand, how could they trust him on the honesty and integrity of everything that he did with the case? So in a way, I don't know how the jury could have found otherwise, other than what they did. So the race issue came into play. Los Angeles was concerned about riots if O.J. was convicted. So a lot of other things came to disrupt a reasonably well-conducted crime scene investigation, and certainly the test that ensued. So that's what can go wrong. Let's talk about kinds of evidence. Okay, and on this slide we have arson evidence and serology evidence. These are two probably of the most interesting types of evidence. Arson is a really common crime. You'd be surprised. Arson is usually committed to cover up other crimes. I'll tell you what I think is almost an amusing story. I say almost because it was a crime. This happened in Massapequa. A husband found that his wife was cheating on him with a man. He knew that he was going to meet her in the house. He went to the house. He killed them both. They were killed in the living room downstairs, and he decided to cover up the crime with arson, and he set a fire upstairs. I'm sorry, folks, but fire goes up. The neighbor saw the fire, called the police department. They put the fire out, never touched the first floor, and they found the bodies. And of course, they figured out what happened. And so that's one reason for arson. The other reason for arson is insurance. Okay. And then of course the third reason is that there are people who really get off on lighting fires, and those are the serial arsonists. What happens with arson is there's two basic types of evidence, maybe three. One of them is the arson investigator will look at the pattern of the fire, and the pattern of the fire usually tells him whether it's arson or not, if there's anything left of the house. The second kind of evidence is the presence of accelerants, and this is if a person used gasoline or kerosene to start the fire. And the third type of evidence is a fuse. What's a fuse? Well, a really good professional arsonist, that sounds terrible, will either create a faulty electrical system, which will smolder and start the fire slowly, or they will create a fuse with a smoldering cigarette. One of the most common ways is to take a smoldering cigarette and tuck it into a book of matches and leave it at the crime scene. The cigarette smolders over time, hits the matches inflame. If the arsonist is smart, he won't use an accelerant. He'll just pile a whole bunch of stuff that can catch fire. And that's how he does the arson. Serology evidence also very, very important evidence in crime scenes. It's blood. In a violent crime, blood is left at the crime scene. And what the job of the forensic scientist is to determine if not all the blood belongs to the victim, but is there blood left by the perpetrator of the crime. Consider a stabbing incident. Violent crimes are not nice and clean and easy. If you're stabbing somebody, what's going to happen is they're going to bleed, the blood's going to get on the knife handle's going to become slippery, your hand is going to slip, and you're going to cut yourself, and your blood is going to end up at the crime scene. The victim may fight back, leaving blood. So it's the hope of the crime scene investigator that the blood or any kind of bodily fluids are left by the perpetrator at the crime scene. Serology really refers not only to blood, but it refers to all body fluids. We usually identify evidence as either class or individual. Class evidence means that the evidence belongs to a class of things. For instance, if we find out that you have type O blood, well, hello, you belong to 50% of the population, so that's class evidence. If we do a DNA profile on you and find a combination of DNA markers that's unique to you, then that's individual evidence. Fingerprints are individual evidence. They are still considered the benchmark of individual evidence. Okay, here we have DNA analysis. What I'm comparing here is how do we find the identity of something? DNA is, in the scientific community, this is considered to be the most perfect way to take biological material and find out who it belongs to. In the legal community, not so much. Because it's based on probability, what happens is, because there's a very, very small chance that it might be someone else's, it is never used to convict, it is used to exonerate. If there's no match, we exonerate. But if there's a match, we need other evidence, which is very interesting. I compared that to a bag full of art pieces. And suppose you find a Renoir you find a painting in your attic, and you think it's a Renoir. Okay, so you take it to the Metropolitan Museum of Art, and you say, would you please try to find out whether or not I have a Renoir from my attic. And the art historians and the scientists will take that painting, subject it to certain scientific tests, but it is actually the art historian's subjective viewpoint that says whether or not it's a Renoir. So there's a lot of latitude here to find out the identity of that particular thing. Okay, so personal identity, again, if we're trying to find out, again, I'm doing blood and fingerprints. Again, fingerprints are considered to be just the benchmark of identification. In fact, we even use this term, fingerprint technique, and it doesn't mean that you're looking for fingerprints. A fingerprint technique in forensic science actually means a test that will give you individual identity. I'm going to give you an interesting case about blood evidence. You would think that identical twins would have identical blood. We can actually differentiate between identical twins because during their lifetime they have probably developed different diseases. Let's say one twin has mumps and the other one doesn't. Of course, today probably they would never have mumps because of vaccinations. But let's say one of them had the norovirus and the other one didn't. There will be antibodies in the blood. We can do an antibody profile and actually distinguish between identical twins. And guess what? We can distinguish between identical twins' fingerprints as well, because when they're in uteri, when they're in the womb, they actually, babies move around, and if they touch the wall of the uterus, it changes the way their fingerprints develop. So there will be very slight changes in the fingerprints even before they're born. The types of patterns, we call the patterns in fingerprints loops, whorls, and arches, those will definitely persist, but there will be some modification between the twins. Not tremendous, but enough to distinguish the two. So identity is something that we really work on in forensic science. Okay, again, now I'm moving into tests. These are some of the tests that we see. When I watch CSI or NCIS, I marvel at the way they show how they do tests. I think it's artistically beautiful. You're seeing something going through a microscope, you're seeing something going through a machine like a chromatography apparatus, but they never really explain to you what they're doing. This kind of frustrates me. They'll tell you the results of the evidence, but they don't really tell you what was happening in there. When you're looking at chromatography, chromatography will give you an identity, a distinct identity. This is a technique that's used in hit-and-run accidents to identify the paint that they find on the victim. It's kind of upsetting to think of the fact that a person who's hit by a car has paint left on them, but there could be paint chips at the crime scene because the violence of the impact actually leaves paint on the victim. They can analyze that paint using chromatography and actually tell the make and model of the car. They do it with lipstick, they do it with ink, and it gives an absolute identity of that chemical. So this is a chemical identification. Compare that to handwriting analysis. Again, there's a lot of science that goes behind this. However, it boils down to the expert saying, yes, this is somebody's handwriting, no, it's not. So that's, again, these are techniques that we're talking about that can give us very good results as far as the evidence is concerned. When you're watching CSI shows, pay attention to that. What techniques are they using, and how accurate is that technique? Okay, there are techniques that are used in the lab that are absolutely beyond a shadow of a doubt. One of them is spectroscopy. By the way, that wand that they pass over you in the airport to look for chemical residue is a spectroscope. It's a very modified one, and it picks up chemical residue from explosives. The best one is the one on the right. It's called gas chromatography mass spectrometer, and this actually can identify chemicals beyond a shadow of a doubt. And what that's used for is drug identification, explosives residue, any kind of a toxicology. So the instruments that are used by the forensic technologists, if you're watching the show and thinking they're doing magic, there are instruments and techniques that are really actually, I think, magic. I don't know if you can read this. It's actually the things that I learned from watching CSI, and one of the things that I think is amusing is it says that all of the female characters are attractive, and it kind of says funny things in there. I actually cannot read it from here, but in my opinion, what I have learned from watching these shows is, number one, they have really good technological assistance, because what they present is really very, very informative in so far as they're showing you forensic techniques. I've actually learned things about forensic techniques from the shows. What I do find frustrating for me as a science person is they don't give you enough of an explanation. And the flaw that I see is that in some of the shows, they show the person at the crime scene unit and the person who is in the lab doing the analysis and the detective who is solving the case as the same person. This never happens. Okay? What happens is there is a detective assigned to the case. There is a trained crime scene unit. The crime scene unit people who process the crime scene rarely ever do any of the lab work. The lab work is done by lab technicians and scientists, and there are specific divisions to the crime scene laboratory. There is a ballistics division that does ballistics, guns and ammo. There's a fingerprint division. The fingerprint does just fingerprints, and it's all computerized. There is a chemistry division where they have what are called wet labs, and this is mostly for drugs and all kinds of toxins. The medical examiner's office is completely different from the forensic scientist's office, from the forensic science labs. The medical examiner will often send samples to the forensic scientist, especially in the toxicology lab, if they suspect, for instance, I guess the most recent case was Seymour Hoffman, who died of quite a combination of drugs that he was using. And of course, they had to wait for the toxicology report to come back to make sure that that actually was the cause of death. Serology, all the blood evidence goes to that unit. So this is basically what happens. And those technicians are not the people who solve the crime. It's not the detective on the street. The detective who is assigned to the crime then gets all of this information and tries to put it together and deduce whether or not they have enough evidence to then go forward and if they have in fact arrested a suspect, whether or not they should go forward to the grand jury. The grand jury looks at the evidence and decides if there's enough evidence to indict. And once they're indicted, then they have to set a trial date. Habeas corpus says you can't hold people for an unreasonable amount of time. So there's all these legal issues. If, they can do all of this evidence analysis, and if there's no suspect, the crime is not solved. Because you may ask, why are so many crimes gone unsolved? Because they don't have a suspect. There's an interesting situation in New York City where they had a serial rapist, and they knew him. They knew him exactly by his DNA, because the DNA was consistent throughout the crimes. They didn't have a suspect, so they couldn't convict. Eventually what happened is this man was arrested for another crime, and somehow or other they took DNA evidence for that, and because he was arrested for the other crime, they matched it up and they were able to arrest him and convict him. So there's a lot to learn from these shows. I believe the satisfaction in watching it is the fact that we can use all this technology and we can eventually get to a point where we can hopefully make society a better place. Forensic science is really close to my heart, and I have to tell you why, and that is because I have, in my career, encouraged girls to go into science. And what I love about the CSI shows is they show very attractive people, girls and boys, men and women, doing sciencey things, wearing lab coats, walking around, peering into instruments. And as having taught science all my life, this really, really makes me happy. So this is very close to my heart, inspiring girls to go into science, and boys too. What I've done with my background in forensic science is I've written a mystery series. I call it Nancy Drew Meets CSI because I loved Nancy Drew when I was a kid, and I taught forensic science for quite a number of years, actually more than 20 years. And I decided to marry the two and write a mystery series. I'll just tell you briefly about what kinds of forensic science I put in my book. The first one is called The Madonna Ghost. It takes place on Fire Island. It is a ghost story, and the ghost is hiding a dastardly plot. In investigating the ghost, my heroine, whose name is Tillery, finds out about this plot. It's too bad. I'd love to tell you that what the plot is, but it spoils the book. Eventually what happens is they convict criminals who are out to commit terrorist acts. So we get into the whole business of how bombs are detected. So that's the kind of forensic science I put in there. Also, we talk about fingerprinting, just the various kinds of forensic science that would be used to prosecute a case. But basically, I ended up with terrorism in this book. You'll have to see how that works out. Girl with Pencil Drawing was about art forgery. There's a movie that's popular right now called Monument Men about the Nazis confiscating art pieces all throughout Europe during during World War II. And actually, that's the backstory in my book. And it's all about Annie Tillery goes, she takes some art lessons, and she uncovers a ring of art forgers. In the midst of that, there's really an exciting conclusion on the Brooklyn Bridge, if you're a Brooklyn fan. But basically, this all had to do with how we authenticate art pieces. My next book, which just went live yesterday, takes place in Turkey. It's at an archaeological dig. And with that, I'd like to take questions, if we can. East Meadow? No, yeah. Any questions from East Meadow?
Which is used more? Is it more with the blood, testing the blood, or is it more with, are you going through all the different systems where they do the combination of everything for testing at the site?
Are you talking about getting blood evidence and how blood evidence is tested?
Is that usually the first thing that's done, or the
No. This is with serology evidence. What happens is because of the fact that DNA analysis is not used to convict, what they do is the standard serological testing, which proves that it's human blood, what blood type it is, and then they do a profile of blood proteins, which really narrows down who in the population could possibly have that combination of blood proteins. They use those tests first. Okay, and sometimes it depends on how much blood they have. If they have a tiny amount of blood, they really have to make a decision as what's going to give them the best results. And I would think with a tiny amount of blood, because one of the techniques you can use in DNA analysis actually multiplies the amount of DNA you have before you test it, they probably would do that. But they do the standard serological testing first. I hope that answers your question. East Northport?
Yes, hello. First of all, thank you for taking the time to lengthy presentation. I have two residents that have two questions. One from Una Meyer, who wants you to just spell out what DNA stands for.
Oh, DNA stands for the substance that makes up your genes. It's called deoxyribonucleic acid. It's actually a chemical found in your genes, not your Levi's, the genes in your the genes in your cells. Next question.
Next question is from Rudy Kodak. Go ahead, Rudy.
Good morning. In today's Daily News, there's a comment by Terry Kennedy regarding her particular case a couple of days ago.
Right.
And it seems that mainstream America is certainly kind of taking the name of Kennedy and a good lawyer that will make you walk. Would you care to comment on this particular case? Because in today's Daily News, there was a comment by hers saying something like, it isn't a very good idea for drunken drivers to be not persecuted, but prosecuted, I guess, proper word. Would you care to comment on this particular case?
Sure.
It seems that the name Kennedy and a very good lawyer will give you a free pass.
Well, that's the consensus of opinion all around in the forensic community and in the legal community. If you have the money to get a good lawyer, you're going to get better representation than if you have a public defender who's really not interested in your case. Not to say that all public defenders are not interested in your case. It's unfortunate. Her comment about not prosecuting drunk drivers, I think that public opinion would say that drunk drivers cause a lot of heartache and mayhem on the road and probably should be prosecuted. Maybe her comment had more to do with what to do with the drunk driver or the drug-addicted driver who is after their prosecution. Should they be put in jail or should they be put in a rehab program? Maybe that's what the comment had to do with. Next question, please. Lindbergh, any questions?
Hi, yes. Do they still use teeth as an evidence?
Oh, yeah. Yes, definitely. I'll tell you, I'll try to make this quick. The Kellyanne Tinez case back in the late 80s, early 90s. She is a girl in Valley Stream. She was murdered by a neighbor. Brutally murdered. She was lured to his house and he really brutally murdered her and he bit her. And it was the first case on Long Island where DNA evidence was used to try to convict him, but because it was brand new, it was confusing to the jury, and he bit her and they had photographs of the bite marks, and the expert witness for the prosecution said that there was a match between his teeth and the bite marks, and the expert witness for the defense said no, it's not a match. And then the prosecuting attorney proved that he was off by one tooth, and that's why he was wrong. So the jury was like so confused. What they did was they asked for the cast of Robert Golub's teeth, because he was the one who was accused, and what they did was they pressed it into the arm of one of the jurors and compared it to the photograph, and that's what convicted. So bite marks are as individual as fingerprints. You just don't often get them at cases. Next question, please. Massapequa, my hometown.
Massapequa? Can you hear us?
Yes.
Okay. We have 4 questions.
Oh my God.
The first one is, what motivated you to go into science?
You know, when I went to school, I really loved social studies. I loved history and geography, but I really had to know how everything worked. So I went into science, and I just, I started all of this in the era of Sputnik and atomic energy, and science was really a very exciting field, and it was well supported by the government and not looked upon as something evil. So I guess all of those factors came to get me into science. Forensic science, I just always loved mysteries, just always. Next question.
Okay, thank you. How long does it take for results of a DNA test to come back?
Depends on which one they use. There's one called PCR. It's polymerase chain reaction for people who like to know what those letters stand for. But that one, it takes about an hour. And it is the least beneficial to the prosecution because it gives a kind of a broader profile, and the other technique, which takes weeks, sometimes 6 weeks, gives you a very extensive profile of the person's DNA. So it depends on which one you use. They use the quick one first because the quick one can eliminate. So you want to be able to eliminate somebody without going through a very expensive test. So they do both. And once they can't eliminate, then they do the more extensive one. Weeks, 6 weeks. Next question, please.
Okay, thank you. Do you think there will be a point in time where we will have forensic information about people from birth so that they can be identified, like so that anyone can be identified in the future if they commit a crime?
Boy, that's a really controversial topic. There are some people who think that's a complete invasion of privacy, and there are other people who think it's the best thing since sliced bread. A lot of DNA analysis is being done on people just because of disease. I don't know where that's going. I'm thinking that in our healthcare system, because of its ability to determine people's susceptibility to certain kinds of disease, their genetic predisposition, it may be used more extensively than a lot of people would hope. But I don't really know. I think there's going to be a lot of court cases on this one. Next question, please.
Okay, the last question is from me. I'd like to know, would you want to come here to Massapequa to do a reading from your book for our book club? We would love to have you.
Absolutely. I live around the corner. Sure. Thank you. Okay. Woodcliff Lakes, New Jersey. Do you have a question?
We have 2 questions, actually.
Okay.
I have a question. A little earlier in your dissertation, you said that there were a lot of innocent people behind bars. I was a police officer detective for 27 years, and I know that statement to be not a fact. I'd like to know where you got your information from.
Basically, I get my information from the Innocence Project. For me, one person in jail who doesn't belong there is a lot. I can't give you percentage-wise, but there are people who are convicted of crimes who are in jail who don't belong there, and the Innocence Project proves that. I'm not certainly denigrating police work. I think by and large it's good, and but it's not infallible. And so my reference was really to the people who are accused of violent crimes such as rape and murder, and then through the DNA evidence, through a subsequent analysis of the DNA evidence, were exonerated of those crimes. So that's where I got my information, and I certainly do not ever mean to say that the police don't do good work, because I think you do great work. Next question.
Thank you. And the second question, we have another resident who works at the Metropolitan Museum of Art.
Uh-huh.
And she was curious, she said that the Metropolitan doesn't verify work that, from people that come in off the street and say, oh, I found this Renoir in my attic. They don't verify those, but does that change when the police get involved? Would they verify work in terms of that?
The police would only get involved if there was theft involved or art forgery. In other words, somebody was trying to pass off a Renoir that wasn't a Renoir, and it was proved to be so. I'm sure that I'm sure she's right. She worked there. However, I just pose this as it's a hypothetical situation, and what I'm saying is that if you find something and you think that it's an authentic Renoir, you will go to experts who will perform scientific tests, and then art historians will look at it. If the scientific tests all come back and say, this could possibly be a Renoir, then some art historians are going to get involved in this because it would be exciting. Whether the Metropolitan Museum does it themselves, I just really used it as, as a kind of an example. So, she worked there, so she would know. Next question, please. Okay, North Hills?
Yes, I would like to know if you're fully aware of the Martin Tankworth case.
No, I'm not fully aware. I do know that he was accused of murdering his parents, and now they found out that he didn't. Wasn't he just recently, they found out it was somebody else? Hello?
Well, they know who it was,
Okay.
and nothing was really done about it.
Well, is Martin still in?
Marty.
He's not still in
No,
jail?
Marty's out.
Okay. I don't know what your question is, though.
Well, I think we better let it go.
What you're saying is that they didn't convict this other person, arrest them or convict them? Are they still alive? I really don't know.
Yes.
Okay. Do we have another question?
Yes, I have one more question. Do forensic scientists have to recuse themselves from cases if they could be prejudiced in any way? Say against terrorism or against particular races or things of that nature?
If they felt that they would be prejudiced in the case, yes, but forensic scientists are often called as expert witnesses in cases. Now, if they are related to somebody involved in the trial, they'd be excused. Recusing themselves, they would have to, I guess, do that based on, as you said, personal prejudices. But they often find themselves in court. In fact, a lot of them make a lot of money as expert witnesses. Okay, I guess the next question or next place? North Hills, please?
Woodmere.
I'm sorry. North Woodmere.
I have a question with that, thank you.
About what? Westbury? Any questions, Westbury?
Someone asked, what was the evidence that convicted Bruno Hauptmann in the Lindbergh kidnapping and murder case?
Oh, did you know that Murder on the Orient Express, written by Agatha Christie, was based on the Lindbergh case? Bruno Hauptmann was convicted on a partial fingerprint that they found on the ransom note. They also said that some of the words that he used in the ransom note were because of his German accent. There was an eyewitness account, but the damning evidence was the ladder that was used to abduct the child. The wood from the ladder was proven to be taken from the attic of the Lindbergh home. And that was a classic case of an investigation by a wood expert and a microscopist who actually traced that wood to the attic. And also, there was money found in his in a closet in an upstairs bedroom. So the evidence was pretty damning, even though there's been a lot of stuff going on even as late as the 90s. I believe his wife just died maybe 10 years ago, but she hired an investigator and a lawyer to try to clear his name. And I think the only doubt left in that case was, did he do it alone? Was he duped? Because that expression, a fish story meaning something is like, or something's fishy, really comes from the name Fish, because one of Bruno Hauptmann's friends, his last name was Fish, and right after the kidnapping, he went back to Germany, and disappeared. So that's where that comes from. So that's the Lindbergh case. No more questions? Okay, thank you very much, everyone. I really enjoyed talking about my experiences with forensic science, and now I hope when you watch the shows on television that you have a little bit more knowledge to make your own judgments about whether it's fact or fiction. Thank you.